Alright, Lesson 3, Segment Relationships, Part 2. The learning goal. Within a lesson, you should be able to use the Pythagorean theorem or the distance formula to find an unknown length, and then explain your choice. So to start off, Pythagorean theorem. If we have a right triangle, our legs, those would be these things. Hypotenuse is always across from a right angle. If I square the legs and add them, so a squared plus b squared, that is equal to the hypotenuse c squared. Should look pretty familiar. So in this first one, my legs are 12 and 9. Doesn't matter what order you do them in. So 12 squared plus 9 squared equals, what I don't know is my hypotenuse, so that's going to be x squared. And then just solve. 12 squared, 144, 9 squared, 81. That equals 225. And then if I square root that, I get 15. So that missing side right here is 15. The hypotenuse should always be the longest side, so just make sure it's bigger than your other two legs. This next one, you'll notice across from my right angle is my hypotenuse. I know that. It is 10. So I'm going to put that over here because that is my C. I know one of my legs is 4. The other one I don't know. So I'm going to call that x squared. So solve just like you normally would. 4 squared is 16. I don't know my x squared, and I know 10 squared is 100. Subtract, I get x squared equals 84. If I take the square root of 84, I get about 9.17. So kind of putting that into a coordinate plane. I have my points A and B. I can find the points of them. A is -1, 1, and B is 4, 7. Now we're going to use the Pythagorean theorem to find the length of this. We're going to do that by kind of squaring off and making a triangle. I know I can count the length of each leg that I just made. And so this bottom one is 5 units, and this leg is 6 units long. So kind of using Pythagorean theorem, I know I'm looking for this side. So that's going to be my x, that's across from my right angle, so I'm looking for the hypotenuse. I know my legs, so I have 5 squared plus 6 squared equals x squared. And then solve like we normally would. We have 25 plus 36 equals x squared. Adds up to 61. If I square root 61, I get about, those are about signs, 7.81. On this next one, we'll make a rough sketch. I'm going to go down by 2's, so that's like -2. So 2, 4, 6, 8, 10, 12, 14, 16, and up to 4, 6, 8, 10, 12. Pretty rough sketch. Plot your points. -15, 4. That's my A, and my B is 2, 4, 6, and 11. So I'm trying to find this length. That is what I am looking for. That's my x. So again, we're just going to kind of square it off. Not super perfect, but close enough. And then count. That leg is 7, this leg is 9. And do the same thing, putting them into your Pythagorean theorem. 81 squared equals x squared. 81 plus 49. So 130 equals x squared. If I square root that, I get about 11.4. Make sure you're putting those into your calculator and you're getting out the same thing. Okay, distance formula. Our distance formula, we use our x's and y's from our points. Remember, points come in x, comma, y. So x is the first coordinate, y is the second coordinate. Doesn't matter which one you do first, but I like to keep them from the same point. Notice your formula right here. I would probably write that down. So distance between 6, -2, and -5, 3, round to the nearest tenth. So I got my distance. Then I got my x's are 6 and -5, so I'm going to put the positive one first. 6 minus -5 squared plus -2 minus 3 squared. Do a little simplifying. 6 minus -5, get 11, and -5. Remember, when we have a negative squared, it becomes positive. So 11 squared, 121. -5 squared is a positive 25. Add those two up, get 146. Square root that, and I get about 12.1. So hopefully you can write down the Pythagorean theorem and the distance formula. Go back if you need to look at anything. And you have finished this lesson.